In our previous videos, we've had a little look as to what actually is an atom and what can we find inside an atom. We've also had a look at understanding the specific charge. And in this video, we're going to take a closer look at one of the main forces in physics, the strong nuclear force. In the previous video, we talked about what isotopes are, and an isotope is essentially just an atom with the same number of protons and a different number of neutrons. But any stable isotope has a nucleus that does not disintegrate. So let's say we've got a nucleus here of 2 protons and 2 neutrons. Any stable isotope we'll have a nuclei that will not disintegrate. Okay, so here's our atom and here's our nuclei in the middle. Now, there must therefore be some sort of strong force that is holding them together, okay? And we call this force the strong nuclear force. That's because it overcomes the electrostatic force of repulsion between the protons in the nucleus and keeps the protons and neutrons together. You see, if there's 2 positive protons, you would expect them just to fly away from each other. Like if you had 2 positive magnets, they wouldn't attract. So there's got to be some sort of force, and that is the strong nuclear force that binds these protons and all these other things together. Okay. So here are some other further important aspects of the strong nuclear force. Now, the range of the strong nuclear force is no more than about 3 to 4 femtometers, okay? That the range equals 3 to 4 femtometers, okay? Where 1 femtometer is equal to about 10 to the negative 15 meters, okay? So it's extremely small, okay? At 0.0000000000000000001 meter, okay? And that range is probably about the same as the diameter of a small nucleus, okay? So here we go, our little nucleus in there. It's about the same diameter as that, okay? In comparison, the electrostatic force between 2 charged particles has an infinite range. So, if we had an electrostatic force, it would just go on forever. But the actual power of that does decrease as the range increases. Okay. The other important point about the strong nuclear force is that it has the same effect between 2 protons as it does between 2 neutrons, or a proton and a neutron. So remember, we just did this little square in the middle here. Well, it has the same effect between these guys, has the same effect between our 2 protons. It also has the same effect between the proton and the neutron there. And the other strange thing is the following, and I'm going to show you a diagram now to show you how the force operates at different ranges. Here we can see a force diagram for the strong nuclear force, and also we've got the electrostatic force on there. And we can see that from 3 to 4 femtometers down to about 0.5 femtometers, there is an attractive force of the strong nuclear force, okay? And at separations smaller than this, it is a repulsive force that acts to prevent neutrons and protons being pushed together. So essentially, the gap between the protons and neutrons is allowed by this repulsive force that happens below 0.5 times 10 to the negative 15 meters. And then but they're not just completely fired away from each other, because after that there is a very strong attractive force that ensures they're kept within the nucleus itself, and that is shown very clearly by this by the strong nuclear forces curve here. So it goes down like this, and it goes up here about 0.5 times 10 to the negative 15 meters, below it has that repulsive force, but then afterwards it has a very strong force that keeps them all in place. Okay, so this is really showing how the strong nuclear force varies with separation between two protons or neutrons. And then we got the electrostatic force, however, that is very, very strongly repulsive when it's very close together. But although this goes on to infinity, essentially, it does get a lot weaker. And so the further you are away, the less that force is. So that really wraps up the strong nuclear force so far. We don't need to go into any more depth at the moment. Just know that this is a very short range force, and it is repulsive below 0.5 times 10 to the negative 15 meters, and then it's very attractive after that to ensure that everything can be kept tightly compact within the nucleus, and that ensures that they do not disintegrate. So if you have any questions about this video, make sure you leave a comment below and I'll get straight back to you. And this sort of topic will make more sense as we move through the course. But I wanted to give a quick introduction at this stage just so that you got a general gist as to how the strong nuclear force operates.